This presentation is on interrupt handling. It is about interrupt processing in digital systems. You'll understand how digital systems respond to external events and manage concurrent operations. An interrupt is a signal that temporarily suspends normal program execution to handle urgent events or requests. It is triggered by asynchronous events, causing the system to perform context switching, which ensures a time-critical response. There are mainly two types of interrupts: internal interrupts and external interrupts. Internal interrupts are generated by the central processing unit itself. Examples include software exceptions and division by zero errors. External interrupts originate from external devices. These include hardware signals and input or output operations. The interrupt processing cycle involves 4 key steps. First, an interrupt request is generated by either hardware or software. Next, the current program state is saved through a process called context save. The interrupt handler, also known as the service routine, is then executed. Finally, the system resumes normal execution through context restore. Interrupts can be assigned priority levels, where higher priority interrupts can preempt lower priority ones. High priority interrupts are reserved for system-critical tasks, medium priority for input or output operations, and low priority for background tasks. Nested interrupts allow multiple interrupt service routines to be active simultaneously through stack-based context management, interrupt masking control, and proper priority ordering. An interrupt vector table is a memory structure containing the addresses of interrupt service routines for each interrupt type. As you can see on the screen, 0x0000 contains reset handler address, 0x0004 contains non-maskable interrupt handler address, 0x0008 contains timer handler address, 0x000C contains universal asynchronous receiver transmitter handler address, and 0x0010 contains general-purpose input-output handler address. An interrupt service routine, also known as ISR, exhibits several key characteristics including short execution time, non-blocking operations, minimal stack usage, atomic operations, and a quick response. This code block is the example of the timer interrupt service routine. It clears the timer flag, updates the counter, and sets the next interrupt before restoring the context and returning. Interrupts have numerous real-world applications. These include real-time systems, which are used in process control, robotics, and embedded systems. They are also essential for input or output operations like keyboard input, disk access, and network communication. Interrupts enable multitasking in operating systems through task scheduling and context switching. Finally, they are crucial for error handling, managing system faults, hardware failures, and exception processing. Interrupts enable efficient and responsive digital systems by allowing immediate handling of critical events. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.